So far, so good. I usually delegate the task of going through the data and then exploring your data as exercises. But this one is a different story because it's going to help us focus on collecting data and how do people actually in reality collect data, which we know is a source code for deep learning. We learned about labeled faces in the wild. It has few identities, around 5,000 or 6,000, and it's a small data. These celeb faces and WD-ref are also small, relatively speaking, for training a deep model. The result that you just saw was from Facebook. They have this many identities, and they have a lot of data, a lot of images. But this data set is not public. There is also a data set from Google, 8 million identities, 200 million images. That one is also not publicly available. Where you see ours is this deep face recognition data. This one is going to be available. It's not as big as the ones that Facebook and Google use, but let's see how they collected the data. And these are the data sets, some examples of the data that you're going to see. Some faces of celebrities. How do you do it? It's going to have a multiple stage process. In a stage one, you're going to generate a list of candidates or the list of celebrities, the names of the celebrities. You collect 5,000 people. You go on the internet and you collect 200 images for every single person. And that's going to give you 1 million images in total. Then you're going to expand the set of your images. How do you expand it? First, you're going to filter the identities that you don't have enough images for, or the images are not high quality. This is a manual process. It means that you're going to design an interface for a bunch of people to go ahead and select the ones that have high quality images, or the celebrities that have high quality images. And out of 5,000, you're going to end up with 2,622 identities. For those, you're going to go ahead on the internet again and then collect more images per each identity. And then that's going to give you around 5,244 images. And this is going to take a group of people around 4 days to collect those data. You're going to have 2 automatic procedures. One of them is ranking the images so that you remove the low quality images per each person, per each identity. So now you're reducing the size to be 2,622. And this is a measure of the quality of, because you're doing it in an automatic fashion, you're ranking. You can look at the ROC curve. We just saw the ROC curve for an automatic algorithm that does that. I'm going to tell you what that is shortly. Then you're going to remove the near duplicate images. You're going to end up with 623 images per person. That's going to give you around 1.5 million images. You can also go ahead and do another round of final manual filtering. So this is manual, this is manual, this is automatic, automatic, automatic. Let's go a little bit more into the details. Where do you collect these images and the names of the people, the famous or the celebrities? You're going to get them from Internet Movie Database. These are the names. You're going to get them from Free Knowledge Graph. And the images, you're going to scrape Google. You're going to do Google image search. What are these automatic algorithms? They are based on machine learning. You go on Google for a single person, you collect the top 50 images in the list for that identity. And these are going to be the positive training cases. You're going to collect 50 images of all the other identities or some other identities as your negative images. And you're going to train a one versus rest support vector machine. So it's just a classifier. Classify this person. Because some of these 2,000 images might not be images of this identity. So you're going to remove 1,000 of them. So you're going to score them according to your classifier and keep the top 1,000 ones. So the idea is that these are definitely the images of this person. Because while you do your Google search, it might show you images of other people. So that's how you're filtering it, using a classifier. And that classifier is based on a feature vector descriptor. So this has nothing to do with deep learning. You're featureizing your images, and then you're using support vector machine. The near duplicate removal is based on clustering. You're going to featureize your images using VLAT descriptor. You cluster them, and the ones that belong to the same cluster or are really close to each other, you're going to keep only a few of them. And this is the way that you're going to remove the duplicates. It's going to give you out of 1,000 images per each identity, you're going to end up with 623. Even this final manual filtering is not totally manual. You're going to use an AlexNet architecture, which is trained to discriminate between these many faces or these many classes. This is the actual architecture. And then the way that you're going to do it is you show those images, you're going to end up with some scores, and then you're going to keep the highest scoring ones out of 623. You're going to keep 375. This is the final manual filtering, and this is going to give you a clean data. So you have two stages. You have two choices for your data and a lot of configurations for your architecture. It turns out that C is the clean version of the data, and F is the one that you have here. It turns out that, yes, having clean data matters, but at the same time, having more data also matters. And it turns out that you're going to get less performance out of your clean data compared to the larger size data. So that's why you're going to work with this version, which has these many identities, and it's around 2.6 million. So this final step was not that necessary. Okay, so far so good. What are you going to do? You're going to learn a face classifier. You're going to learn a first embedding using a triplet loss. Face classifier is what we did for the first slide of today. Face embedding and learning face embeddings is what we used previous slide when we're doing FaceNet and triplet loss. Whatever that you do, you can apply your algorithm on top of labeled faces in the wild. So now you're doing some transfer learning, and then you can look at the accuracy of your model. And it's competitive to FaceNet, which is trained on 200 million data compared to 2.6 million data. And we learned that to judge the quality of these methods, a good curve is the ROC curve, which is false positive versus true positive rate. And this is what you're going to get out of this method. I think it would have been better to zoom in, but anyways. You can also apply to YouTube Faces data. And then you can compare to FaceNet, which has more data, and that's going to give you 95 accuracy. This is going to give you 97 accuracy. I think it's a good time for me to stop. For those of you who have questions, I'll be around.